Hello everyone, this is Mr. Crow with another Greenfoot lesson. Today we're going to be learning how to do a top-down shooter. We're going to create a world that's a little bit taller than this, and we're going to have our main character, our player, down here at the bottom, and they'll be able to move left and right and be able to fire projectiles at incoming enemies that are trying to reach the spaceship at the bottom of the world that this smaller ship that is your player that is going to protect the mothership. So we're going to add objects randomly, having them fly down and try to hit the bottom of the world. And we're going to have projectiles. We're going to learn how to shoot and fire towards the enemy. And if you hit it, we're going to have a score counter up here, as well as a health bar for your mothership and a timer to see how long you can survive. So we're going to be adding in quite a few things in this multi-part video. So to get started, we're going to change the size of our world to be the correct size. So if you double click on your world or right click and open editor, you will find the size is 600 wide by 400 tall. And so our size is going to need to be almost double that. So we'll test what 700 looks like for our height, and that's a little bit too big because I don't want to have to scroll. Your size might be a little bit different than mine, so let's do 600 by 600 and see how that works. Perfect, almost reaches the edge. That's plenty big enough for us to get started. And so since we're in space, might as well have we got to right click, set the image of our world, and get a background. That's a space background. Which one you choose doesn't exactly matter, but I'm going to choose this one. I like this one a little bit more. And so we have our space background, and we're getting ready to get going with that. So we can add our main character in, right click, new subclass. I believe must be under transportation for our rocket. Similar to our other game, you could create download an image and enter it in here, and you can go to a previous game to figure out how to do that. You would just go into set image, and then you'd import from a file, so you need to make sure you save your images inside of the name of the Greenfoot world, which I've called top-down shooter, and then you can plug it in there and grab your images from in here. So we might do that a little bit later, but we have our object facing to the right because this is in Greenfoot. This is rotation of 0, so it'll always start off facing right. Most of your characters are made that way. So if you want your character to change its rotation prior to the act method, so you would need to create a constructor method, and a constructor method happens prior to the main method. So in Greenfoot and in programming languages, your main method is the one that gets run when you execute the command, or the main series of things that you want to have happen. A constructor is built in. Might happen before, it might happen in a different time, but it changes the characteristics. It constructs something to do with the class. So this player class, if we want to change the size of it, or we want to change the rotation of it, the physical properties of it before the act method, you would need to create what we call a constructor method. And so you would have not a return type, which, remember, void is the main return type that we'll use in Greenfoot, but later on I'll explain what other return types are possible. But this is our return type. We will not have one. You never have one in a constructor method. So if I want to set my rotation to something different, I need to do the set rotation command, and it's going to ask, if I put a semicolon here, it's going to say there's an error found in class. Okay, all right, what's my error? If you highlight over it, method set rotation will expect an integer. So if you see right here, it says required int found. What did it find? Nothing. It found no arguments. And the reason, actual and formal arguments lists differ in length. So it's expecting an int. So required is an int, but it doesn't find an integer. So we need to create an integer. So if to the right is 0, down would be 90. Just rotate it clockwise, until you get to the spot you want it to be. So if I wanted to face up and I started facing to the right, going right, then I'd go down would be 90, left would be 180, and up would be 270. Okay, so 270. And you can always do negative 90. It would go counterclockwise the same way. So if you don't want to count all the way up to 270 and you want to go negative 90, that works as well. So now when we enter this in, it'll face the correct direction. You can right click and save the world just so you have this guy in here ready to go. And then the first thing we can do is create our player movement. So our player, we have its rotation. We're going to have a move method, so a move around is what I like to call it. Move around method, and we're going to create that method. Right now there's an error, but once we create a public void move around, then in the act method, that main method, it will access the move around method, and so we're calling the move around method in. So our move around method needs to move just what do we want the character to do. So stop and think. If we just want him to slide left and right, we need to have two buttons that push, one button that pushes it left, one button that pushes it right. It's simple as if Greenfoot.isKeyDown right. Set up our blocks, curly brackets, correctly so that our if statement is ready to go. Okay, and it's telling me that there's an error, and then I read what it says. So if you highlight over it, in previous versions it would show up the exact explanation down here, but this newest version of Greenfoot, it'll show this information. So it expects another parenthesis. So I notice that if I highlight this parenthesis, it covers this one, and then I keep tracking back. Oh, there's another open parenthesis. I need one more closed parenthesis. Okay? And if I put one too many, that will look funny. If I put the right amount, we're good to go. So compiled, no syntax errors. Perfect. So if the right key is down, we are going to not move it if we move 5. And this is part of the reason why I don't like this command as much as what we've changed it to, which is that set rotation. In the first lesson, you learned about moving forward. Well, if my rotation's 270 and I want to move right, you know, when our rotation's 0, we move to the right. But if my rotation, so now if I push right down, I move forward. I don't want to move forward. I want to move to the right. So that's why that set location, get x, and our x is 0 on the left side and 0 at the top. Our y is 0 at the top. Our x is 0 on the left side. So if I want to get away from 0, move to the right, away from this left side, then I would have to add 5, comma, get y, and I wouldn't change the y when I'm pushing right down, so I don't do anything to the y. Now, it's as simple as, copy, paste, change right to left, and what do we do to the get x? Instead of adding to it, we're subtracting to it because we're getting closer to that 0 on that x value, to x equaling 0. So now we go in and we can now move left and right, and I like being able to move decently quick, so when we add our characters in, it will be a little bit easier to go left and right and hit them and be able to get to them. So now we need to create an enemy class. So call it enemy, and it's going to be a super class because we're going to have more than one type of enemy, but we want them all to be moving the same way, or at least in a similar way. So we are going to just create an enemy superclass, and then a subclass of enemy will be enemy 1, enemy 2, enemy 3. You can do that. That doesn't specify the enemies quite as well as some other things, but you know, you're able to. We can get started just by doing it like that, and if we want to change it later, we can change the name later. So add in enemy 1, the robot. See, the problem is is that it's facing to the right. We never want it to be facing to the right in our game. There would be no reason for it to be facing that way. So we're going to do another constructor, because a constructor does what? Well, it creates the physical properties prior to the main method, the act method, being run. So we can change, right when it gets in there, we can change the rotation. Instead of to 270, we want to add or subtract 180 to it. So if I subtract 180 from 270, I get 90, which makes it face the opposite direction as the rocket. So it'll face down. Okay? Now, I have my enemy. They will not move based off of an if statement. Okay, so I'm going to need to create a move command for them. Move enemy. And you can name this whatever you want to name it. That's why I wanted to not name it move around, because you don't have to name your methods the same. You don't have to name them the same as me. You can name them shorter things if you think that saves time, but being as direct and as clear on what your enemy is doing is very important. And actually, I want to have all my enemies move the same way. They're all going to be moving down, so I might as well put it in this super class, create a move enemy, so that whatever I put in here, that's how fast they're going to move. So they are going to be moving forward, so I could just do move 3. But maybe you're setting an image in there and you're not going to rotate them, so they're actually not going to be facing forward. That's why it is always safe, because if you add in, let's say I put move in there, okay, and then you would have to go into, so in enemy I have the move enemy method. So in order for this to be, this enemy 1 to access the move enemy method, I have to put in move enemy. And where before we had to have a method inside the enemy 1, like down here we had to have a method, now we just have it in here. And so I could have 20 different enemies, and all I'd have to do is put move enemy method instead of copying this and pasting it and changing it and doing this, that, and the other with it. So the move enemy, so we'll compile, and now if I add in an enemy, they'll move down, and that's great. They'll move down at the speed that I tell it to. But let's say you add in or change this image so that it starts out facing left. The image that you happen to save just starts out facing left. If I would have to change its rotation all the way to the opposite of the direction I want it to go, because it starts off not facing 0. Its rotation, it'll be facing left, but the rotation will be 0 if at whatever the originally saved image is. So this image is originally saved facing right, so that's going to be 0 for that image. And then for another image, it could be starting off, if you save the image and it's facing left, at 0 rotation it'll be facing left. So then if you did just a move command, it would go backwards. It would go the opposite way, because it's starting off facing the opposite way. So its forwards is going to be opposite of what the one facing right is. If you have it start, if enemy 2 is facing left to start off. So that's why it's always easiest to have it. It just covers your basis. If you have, instead of move, you just have set location, because this is not taking the original direction of whatever. It could be facing diagonally, and it won't matter. It's going to be relocating just down. So if I'm going down away from my y value equaling 0, I'm going away from this 0, I'm going to have to add to the y. So I'm going to add 3. 5 was going pretty fast. So now my enemy, well, it says it expects a parenthesis, and that's what I forgot. This now is closed off, and now we're good to go. So I plug this in. Perfect. If I add another enemy, of a building. Say this was enemy 2. This is just for an example. And I open editor and have enemy 2, and I do my move enemy. If my move enemy, now it'll move down. The problem is, and see if this is the way I wanted it to face. Problem is, if I would have just done what I was explaining earlier, move 3, since this facing down is what it starts at, and this faces right normally to start with, this would be a problem. They would be going different directions. So that's why using the code set location is much more practical. But I just wanted to show you in case you wanted to use the move forward code. Sometimes you might want to use that. So now if we go back and we do it correctly, these two will be moving at the same speed. Okay. Now I want to actually add these objects in randomly. And so I'm going to have to go into, so if I have them moving randomly throughout the world, what am I changing? That's always what you want to ask, where to put your code. Well, what are you changing? Are you changing something to do with the player class or the enemies? You're not changing the enemies. You're adding in the enemies. You're changing the world, the environment that you're in. You're changing it. And it's good to know you can put it in the world class because the world's never going to disappear during your game. You're never going to just not have your world class there. So if I open my world, okay, I have, since I've saved the world, it automatically creates this prepare method for me. And this prepare method goes into this already made constructor class for my world. Constructor for objects of class my world. The notes, the comments even help you out with that. And it's telling you it created a new world, well, at originally 600 by 400 cells with a size of 1 by 1 pixels. And this is the 1 by 1. So that's what this 600, 600, X value, Y value, and 1 by 1 pixels. So we're going to have to create where all the other classes, all the actor classes, automatically an act method is in there, because you know when you're plugging these in, more than likely there's going to be something happening unless you're adding objects in there that are just there for scenery or background and don't really have any movement or any commands in them. But in the world, not always do you have the world doing anything or doing an act. So you need to create your own act in order for anything to happen. So we're going to do a public void. We're going to create a method inside the world that is an add enemy 1. And there are other more complicated ways to add all enemies in, but we're going to do one enemy at a time. That's just going to be the easiest way to do it for now. So in order to add an enemy into the world, you need to create a command that does that for you. And normally we would do a get world, and we'll be doing that later, so we can access the world, because what we're changing, like we said earlier, is the world. And so being able to access the world class in order to add these objects is necessary. It has to happen. But we're already in the my world class, so we don't need to do get world. We can simply do add object. And what object are we going to add? Well, we're going to add enemy1 dot class, and then it's going to ask, when you add an object into the world, it wants to know where the object is located. It can't just guess that you want the enemy1 class to be at the top of the screen. The computer has no idea you want that to be where it's located. So what we're going to do is we're going to need to make the X value random. And so we're going to have to do greenfoot.getRandomNumber, if you remember that from the last lesson. And it needs to be a random number between, well, the size of the world, so the width of the world, so 600. So 600 comma, what do we want our y value to be? Well, we want our y value to be 0 because we want it to be at the very top. Okay. And it's not going to be enemy1 class. We're going to do one specific instance of enemy1. So just like in the prepare method, how we have like new player, this is doing one instance of the class player. Now, to do one instance of anything, you have to do new. So I'll do new enemy1, and that will add in the enemy1 player. Now, that compiles, no syntax errors, but we need to add this, just like in our actor classes, we need to add this into the act method for it to happen. And I'll tell you, this will be a surprise, I feel, to everyone, but if you remember, when our speed is right in the middle, it executes at 60 times per second. So we're going to be adding in 60 objects per second and can crash your computer very quickly. But that's a little bit too fast for us, and they're not disappearing at the end. And so eventually you'll see that our object, our Greenfoot, will slow down, and eventually it'll crash the whole thing. So we need to change this up somehow, and we need to make it happen less often. So there's a few ways you can do that. I'm going to do it with just a random number. So if greenfoot.get random number, because we don't want it to happen every 5 seconds. You could have that happen. We want it to happen randomly, or at least I want to have mine happen randomly. So that 60 times per second is much too fast. So if I did get a random number between 0 and 60, and if the random number is less than 1, so if it's 0 basically, so there's a 1 in 60 chance that it will happen. That, if you are good at math, will make it just about happen once a second on average. So if we test this, if Greenfoot, will you please get a random number between 0 and 60? So the first time it gets a random number, then this happens 60 times per second. So the first time it gets 0, or it gets 50, then 23, and then 17, and then 49, and then 12, and then 2, and then it randomly gets 0 on the 30th time. That would be half a second, because this happens 60 times per second. This process happens 60 times per second. So there is a 1 in 60 chance that it will be 0. And so there is a, if it happens 60 times per second and there's a 1 in 60 chance, it'll happen about every second. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so just about exactly what we're looking for. I didn't even give a chance for 10 to finish out. Maybe that's the 10th, okay? So you can see how now it's working the way we want it to. If you didn't want it to be random and you wanted it to actually happen once per second no matter what, you would need to create a variable up here outside, just in the class, outside of the act method, so it doesn't reset every time. And you would have to create int count, or enemy count equals 0. In the act method, enemy count plus plus, and if enemy count is greater than 59, we're gonna add an enemy, and then we're gonna change enemy count back equal to 0. Now, quickly, what this does is it creates a variable that starts at 0. This plus plus means 60 times per second it will count. It will add 1, add 1, add 1, add 1. So it'll be 60 in 1 second. So that means it'll add its first enemy at 1 second because it'll be 60. So it'll be greater than 59. And then after it adds that enemy, it'll change back to 0. And then it'll go outside the if statement, and then it'll restart. And still at 60 times per second, it will add. And then this will only execute, it'll only add an enemy when it's 60, and then it'll flip back to 0. So now we can watch it consistently. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So exactly how you want it to work is all it depends on. So if you want it to be random like I do, you can do it the way I did it originally, or if you want it to be evenly adding in the object, you can do it that way too. So I'm going to go back to how I had it with the random numbers and get all that out of here. So now, random number, it'll still happen about once a second, but it's just going to be more random. So it could happen twice in a second, or even 3 times, unlikely, but possible. And then usually over time, it'll balance out to happening 1 time per second. If you gave it enough time, it'll always balance out to 1 time per second, but it's just random. So it could happen or it couldn't. Okay, that's it for this first lesson. We learned how to set up our player, add in these enemy objects. These enemy objects are moving randomly down to the bottom of the screen. Next time we'll remove those enemies. We'll start firing the projectiles. We'll add in a few more enemies and get us going further along with this top-down shooter. Thanks for watching. I'll see you next time.